Welcome everyone, this is Tim Pullman and you're listening to the SAP Couch. This podcast is all about standard essential patents. We talk about patent strategies, friend licensing, patent pooling, and patent litigation. So let's dive into today's episode. She is the Vice President and Chief Technology Officer for Technology Policy and a fellow at Cisco Systems. She leads and supports the company's technology policy work on artificial intelligence, on broadband, on technical standards. In fact, she was the first female chair of the Internet Engineering Task Force back in 2017, a position she held until 2021. And I'm super happy to have here now in my podcast, Alissa Cooper. Hi, Alissa.
Hi, thanks so much for having me.
It is my pleasure, and I'm really, really happy to have you here on my couch. And I'm starting my podcast always with the first question about, your personal career, your CV. And I think you have a very impressive CV because it's not a normal one. And I would love to hear from you, and if you would walk us through a bit of the steps in your career, elaborate on how you entered the world of technology standards and these topics that we care about here.
Yeah, absolutely. So the way that I got into standards was that I was actually working at a think tank called the Center for Democracy and Technology, based here in Washington, D.C., where I live. And it's abbreviated as CDT. So CDT was working at the intersection of the internet and civil liberties. I was doing a lot of work on privacy, and there was a project out of the organization specifically focused on trying to enhance privacy in standards development. So my manager asked if I wanted to start taking a look at some of the standards that were being developed in the Internet Engineering Task Force, the Ietf, as well as in the World Wide Web Consortium, the W3C. So those are the two standards organizations that I know best by far. So I started participating in the Ietf and was particularly involved in some geolocation related standards that were being developed at the time. This was kind of in the mid 2000s, thinking about the move from traditional voice services to internet-based voice services using SIP, the session initiation protocol, and other internet protocols. And so we were thinking a lot about how do we carry geographic location information for the purposes of emergency services when we're moving from the PSTN to the internet. And there was a bunch of standards activity that had grown out of that. And I was very interested in the privacy aspects of this, because once we start, embedding location information into lots of different internet protocols, you need to think about the privacy properties of that information. So that's kind of how I got started. And my very first IETF meeting, I totally fell in love with it. I thought it was just like such an interesting set of people, an interesting organization. I had learned about it a little bit in school, like when I learned about TCP and IP and whatnot, but I had no idea sort of the colorful characters that were involved and the way that the organization worked. And I just thought it was really neat. So I got hooked and got to spend a bunch of time in the working groups doing technical work, but also was soon appointed to the Internet Architecture Board, which is one of the leadership bodies of the IETF that looks after the long range implications of the internet's development. So I kind of moved my way up through different leadership levels in the IETF, starting with the architecture board. I later moved on to being one of the directors of the applications in real-time area, where all of the web and voice and video protocols get standardized. And around that time, kind of in the intervening years, I did my PhD, finished my PhD, and was recruited to Cisco, where I work now. So when I started at Cisco, I was spending about half my time on standards leadership in the applications area in the IETF. And then I was doing a lot of privacy architecture work inside the company. And in 2017, the opportunity came along to apply to be the chair of the IETF, or it was 2016, I guess. And so I put my name in the pool for that, and I was appointed as Ietf chair in 2017, and I served in that role for 4 years, two-year terms, completed that last year. So that's a brief summary of my journey through standards and standards leadership.
Very, very impressive, and very interesting. And I'm always impressed also by this, what you said, you were hooked with Ietf work. And I think that the cooperative nature of standards development is also something that I think is very fascinating. In our podcast, we talk a lot about standard essential patents and leaders and patent owners. However, standard development is much more than just getting an SEP implemented in some standard. In your view, when you think about standards leadership, why do companies develop standards? Why do they spend a lot of R&D to send people to these meetings? I mean, this is really a massive investments of people and time, and also R&D that they put into the development of these standards. Why is it so important to companies to be part of that and shaping the future of these standards?
Yeah, so I think, for the kinds of standards that I've been involved in, really the baseline motivation is around interoperability. So you can look, as a technology company, you can look at a market and very rationally understand that no matter how successful you are as a technology vendor, you are not going to own the entire market. You're going to have customers who multi-home. There are going to be entities out there that choose to go with a different vendor who isn't you. And as a result, if you don't want to, limit your market footprint only to the customers that you serve, but you want to be able to, exchange traffic with other entities out there, then you have to have some interoperability. And this is something that Cisco figured out decades ago, long before I joined the company, how crucial this was going to be to the future of its business as offering routing and switching for the internet and really building the internet itself. So I think this is actually really the main motivator for a lot of networked technologies, is to build a base which is common across all the vendors, all the developers in the space, and then allow for value-added differentiation on top of that, which is all the bells and whistles and features that you don't standardize, but that you offer as your special sauce to your customers, knowing that they can achieve baseline interoperability on the basis of standardization. And I think, obviously, being an internet person, this is extremely powerful, because without this baseline interoperability in the core protocols, we wouldn't have a lot of the other amazing innovation and applications that we've seen grow over the last several decades. We need that baseline level of interoperability. I think from a country perspective, it's different, right? So the calculus is very different whether you're sitting in a private company or whether you're, a government that's thinking about this. And I think from the government perspective, they look at standards through the lens of economic competitiveness and industrial policy. So, they might think about standards as a lever to shore up their own economies, in the same way that they look at research or scientific development or access to venture capital in the country, right? These are all different levers that can help stimulate their own industries, make their own industrial players more successful. And I think both of these things can be true. You can have a very strong technical motivation to interoperate, and you can also, view standards at a national level as a basis for, being successful in a global economic competition.
Yeah, and I think about that specific discussion is also how you and me first came into contact or contacted each other. As I remember, we looked at standards leaderships and companies that are involved in different organizations. And you said that Cisco understood this early on. And I think as a result, it also shows in our data counted by contributions that Cisco is one of the strongest Ietf contributors over the past years. And Ietf is quite US focused, I have to say, thinking of a country perspective. It's quite an American organization. And in that regards,
thinking a little bit even high level about governance and all these different organizations. Can you elaborate a little bit about how this works? So in organizations like Ietf is a private standards consortia, same as the W3C, but then we also have national bodies. In the US, it's the ANSI, and we have other governmental organizations like the NIST. Can you give us like an overview how these different organizations work and what role these have in the ecosystem of standards development?
Sure. Yeah, I'm happy to do that. And I will just say, I think many people inside the Ietf who would disagree with you about it being an American organization, but I know that you have a particular lens on the data, and we can save that argument for another day. But the way that I would think about this governance question, first of all, is to understand that there's a huge spectrum. So the landscape of standards development organizations is extremely diverse, and there's kind of many different axes along which you might compare them. No two SDOs really have exactly the same governance. And that diversity is a virtue. It's really good that we have this diversity. Sometimes you hear about the sort of fights between SDOs, or that they kind of look down on each other for being too formal or not formal enough, or too much voting or not enough voting or whatever. But in reality, the fact that we have so many different models actually means that we can meet the market needs of different players, no matter what they are, and that's a good thing. So on one end of the spectrum, as you noted, we have the kind of private consortia style model, W3C, IETF, IEEE, Broadband Forum, Cable Labs, Bluetooth. There's literally thousands of these, and these organizations tend to be very much private sector led, more informal. They like to operate on the basis of consensus, more so than voting. And this, I will to pick out the particular example of the IETF is particularly true in the IETF, where there actually is no membership and therefore no voting, and everything is consensus based, which means that we try to get the group of people who needs to decide something tries to come to an agreement. If there are objections, those objections get raised, and the group determines a way to address objections, which doesn't always mean accommodating them, but means that they get addressed. But there's no kind of quantitative voting necessarily. So this is kind of one end of the spectrum. These organizations, I would say, in general, tend to be kind of more technology driven. Have more engineers, architects, operators, academic scientists kind of showing up in these venues, and those are the people who are doing the work, debating and designing new technologies and the standards that go with them. And so it's very, very kind of engineering driven. On the kind of other end of the spectrum, you have what some call the big three, right? The formal SDOs, ISO, IEC, and ITU, and very different model, very formal, to some extent driven by national delegations, national constituencies, or even in the case of ITUT, sort of one government, one vote kind of model. Can be get a little bit more political, a little bit less technical, and they produce more standards that are than just technical standards. So they produce kind of process style standards and frameworks and things. So this is a very different model, but one that regulation relies on, that governments are very keen to ensure that system with those formal organizations continues to exist, so that they can reference those standards in regulation and so on. So that's kind of the other end of the spectrum. And then you have organizations that are kind of somewhere in between, or operate differently. Say an organization like 3GPP, which has some formality to it because it's like an official, partnership created from several regions of the world, but is also very engineering driven and seeks to make decisions on the basis of technical merit. So you get organizations that are kind of a hybrid. And then you asked about ANSI and NIST. There are in every part of the world regional and national organizations, whether governmental or not, that are helping to either consolidate the government's positions around standardization, or just provide accreditation and other services to the standards community. So in the U.S., you have NIST, which is the government agency that coordinates standardization on behalf of the U.S. government. You have ANSI, which is the accreditation body for standards development organizations in the U.S., but it's not creating standards itself. The U.S. having a very, in general, private sector-led standards ecosystem. That's kind of the right fit for here. You can compare with Europe, where you have well-defined European standardization organizations, ETSI, CEN, and CENELEC, that have particular responsibilities in the eyes of the European institutions. So there's a really big variety depending on where you look, and quite a spectrum when it comes to different governance and operational models.
Great, thank you for elaborating. This makes this picture much more clear in my head now, which organization is on where, on which level. Thank you so much. One of the things I keep reading, in particular for these private-led standards bodies, is that their intention is really to be open. They want everyone from the industry to participate, and there's no one blocked to do that, but still with some governmental interest, and some political discussions, or also political crisis, I would say, there are sometimes calls for excluding certain companies from certain countries. Often security is one of those reasons, but also maybe other economic reasoning behind that. What do you think about that? Should standards bodies remain to be open? Should there be even any rule that someone is let out from these bodies?
Yeah, so I will say I'm a purist about this question, and I think the value of openness trumps every other value, essentially. When you have an open organization, what that means is that the potential for getting the best ideas filtered into the standards process is the widest, and that's what makes the best standards. People who think that they can identify all the stakeholders ahead of time and say, well, as long as these 5 people are in the room, we're gonna make the best standard, have not been involved in the standards process for very long. Because what we found, in particular in the Ietf, which is sort of radically open, anybody basically with an email address and who can communicate in English is welcome to participate. You find people all over the world. You find students, you find hobbyists, you find, very senior architects, and everybody in between, who might have an interest in a particular technology, who can come and contribute. And that makes the standard so much stronger. And sometimes, these people materialize late in the process, and they come with data that shows that the design that you are about to finalize is actually broken, or isn't going to work on the internet, or whatever it might be. And that input is incredibly valuable to create standards that actually get deployed and work and cause our technologies to work better. So the basis for all of that is being open to input from anyone and from anywhere. I think what's really wrong with the notion that we need to close off because of some geopolitical concern or some security concern is that a standards process is a competitive process by its nature. I work at Cisco. We show up in all these different standards organizations, as do all of our competitors. We're not there with all of our friends. We're there with all the other companies that are competing with us on a daily basis for business. And that's a good thing. We're there trying to make sure that our ideas win the day. They might not win the day, but we're not there because we all already agree or because we all already trust each other. It's not really a venue that's built on trust. It's a venue that's built on competition. And so the fact that you might have some entities in the room whom you don't trust is very normal. That's how it works. That's part of the process. It's not something that we need to erase by keeping people out. The other thing is that as we start to look at this on as like a government policy or on a country by country basis, it's a total race to the bottom. So one region or country starts excluding, some other subset of countries, then there's retaliation. Suddenly we have fragmented standards that only work in, one country or one region of the world. You have, global companies that have to start to tailor to all these different regions. And that value of interoperability that I spoke about earlier is destroyed. We no longer have interoperability globally. Now we have all these separate, national markets that have different standards. And that's not a good outcome for anybody. It's not good for users and consumers. It's not good for businesses. It's not good for governments who cease to be able to exploit the benefits of scale that come from global interoperability. So I understand why there's some push towards this, or I understand, I think, what the appeal of this idea is, but it's actually a pretty dangerous idea that really undermines the standard system itself if it's carried too far.
Very interesting. And tied to that answer of your question, I have a little bit questions about, how does actually the whole standards development work from idea to, the final standard, and who are the decision makers in between? And if I think about standards development, even if IETF, for example, is an individually based standards organization that is, not by company, but by individuals, could it still be that certain companies send more people to meetings to influence standards development even more? And I'm kind of wondering, how democratic is this whole system, or in the end, really, how does it really work? Like, how do you find this consensus? How big are these groups? Can I imagine this like a conference and someone presents something like a first initial idea, and then others have ideas, and they bring that together, and then someone decides on this? Can you walk us through a little bit that process, and how it can be influenced?
Sure, absolutely. So in the IETF, anyone can propose an idea for a standard, and these get proposed in a particular document format that we call internet drafts or drafts. And really, this is a process that's open to anybody. So, there's a tool on the web. You can post your draft into the IETF's draft repository, and then it's a process of starting discussion on this proposal, seeing what other people think about it. In reality, I think a lot of people do work in the background. They start, so before they even ever publish their draft, they'll socialize their idea with others in the industry, with other people who they know who are active in a particular IETF working group that's working on this technology. They'll try to see, what do people think about this idea before it gets proposed. And I guess I should say, just to give this a little bit of context, in the IETF, there's about 120 working groups approximately working on different technologies spread across 6 technical areas that the IETF focuses on. And some of these groups are, very active and large, and they might have, a docket of 10 or 20 active internet drafts that have dozens of people working on them. And so a total group of 50, 60, 80 people who are, interested in a topic. Others are much smaller, narrower, kind of niche areas, or as I spoke, I gave the example of the emergency services, when in the early and mid 2000s, when this topic was very hot and there was a lot of work to do, that's maybe how many people were showing up and how many drafts there were. By the time we got, 5, 6, 7 years later, there's, 1 or 2 drafts left, and maybe like 5 or 6 people who are still working on it. So you get the whole range in terms of engagement from the IETF community. So once we get to the point of introducing this draft in the IETF, it's considered what we call an individual draft. It's like authored by the person whose name is on the document, and it's their job to convince others in the working group that it should be adopted by the working group. That the working group should take this on as a milestone, that it wants to progress towards standardization. And at that point, you usually have a call, a call out to the working group for adoption, and you get feedback from people. Yes, I think we should adopt this, or no, I don't. And there's discussion about the pros and cons and whether it fits within the charter of the working group and so on. And this is like I'm giving you the story for the IETF, but it's not that different the details change from SDO to SDO, but most of them have some kind of process here where you can propose something. Eventually you have to decide whether to work on it. And then there's a working group that will do really the bulk of all the substantive work on it until it's in a close to final state. And when it reaches that point in the Ietf, then there will be a working group last call, like the last opportunity for people who've been participating to provide feedback and commentary and suggest changes or to object to its progress. And once all of those issues are resolved, then it goes on to an Ietf last call. When it gets announced to the whole Ietf community, now we're at thousands and thousands of people. We are thinking about publishing this as a standard. This is your opportunity to provide comment, feedback, and what have you. And many of those last calls pass with very little input because all the people who cared about this particular slice of technology were in the working group and they've already provided their feedback. Sometimes they produce a lot of input because this is the opportunity for, in the Ietf, what we call cross-area review. You get people who, if it's a transport document, you have people with a very strong security background who might spot a security issue in your document that nobody else saw because it was in a transport working group, this kind of thing. So there can be a lot more discussion at that point. And once all of that is resolved, it goes to its final stage, which in the Ietf is a review by the steering group that is the technical leadership body in the Ietf. So this is like a group of 15 people who are appointed by the Ietf community to provide the final review of every document before it goes off to be published as a standard. And again, that can be a process which is very lightweight and non-controversial because all the issues have already been addressed, or you might get additional comments from this steering group that require further work before the document can be finalized. And then once it's finalized in the Ietf process, it goes through like a copy editing phase, which can actually be kind of long because these documents are long and complicated and quite detailed, and you want to have match up all the references and do all the sort of cleanliness checks that you would want to have before the thing gets set in stone. And then eventually it's published as an official RFC. So that was kind of a long-winded way of describing the process, but what I would say in terms of the the ability to influence, there's many of those stages, right? So if you really, and what I would also say is just in terms of the, if you send a lot of people, what difference does that make? Or if you're a big company, what difference does that make? I would say those who want to have or who try to exercise more influence, it's more typically towards either delaying or blocking something that they don't want to see progress than it is towards getting a rubber stamp on your own proprietary standard. In the Ietf, at least, getting a rubber stamp on your own proprietary standard is basically impossible. It's very, very difficult to do because it is this community consensus process. And once the working group has adopted a document, the change control reverts to the working group. So even the individual author from the company that originally proposed it no longer really has control over the content. So it's very hard to just get, very specifically the thing that you want standardized to end up that way through all those different stages of the process. But if you have a competitor and they're trying to standardize something that you don't think should be standardized, then there are those many different, signposts along the way where you can attempt to slow it down, raise questions, prevent it from going forward by raising objections to it, either from a technical perspective or from a process perspective. And that's the kind of thing that you see happening in different working groups, and is also totally not specific to the Ietf, is something that also happens in many different SDOs. The thing I would say about it, though, is that sometimes one very effective objector can cause that kind of delay. You don't need to be from a big company or have an army of people with you. Sometimes, having more voices chime in and raise objections can also affect that outcome. But in particular in the Ietf, because there is no voting, and it's not a quantitative measure, sending a lot of people to a particular meeting or to a particular mailing list, it can have an effect. It can be annoying, but it's not really a mechanism for achieving a particular outcome because the decisions aren't made on a quantitative basis.
Great, thank you so much for elaborating on this one. ITF, Alissa, is a body that is also subject to what we call standard essential patents. At least there are patents declared to be potentially essential. And ITF is one of those bodies that have many of those, but there's a difference in the way of how it's declared. While the ITF requires those companies to disclose the knowledge of IP that potentially is essential, they don't really place much requirements on, requiring a certain royalty payment. I think even most of those declarations make clear that these patents will be royalty free. If you think about this IP policy compared to an IP policy, let's say from ETSI or 3GPP, where patents play a big role, do you think that it's easier to govern standards that have a more open IP policy? Or on the other hand, could it be also that certain companies would not join or not integrate certain technologies that are patented into the standards development because they want to keep the patents for themselves and not, provide access to those? Do you see any relation there, or what is your take on this?
Yeah, so I think this IETF policy, which is basically that that patents should be disclosed, and that's the start and the end of the policy, that patents should be disclosed. What it does that's quite useful is that it kind of democratizes the process of deciding what the implications of the IPR are for standardization, because it gives everybody the same information, or it's supposed to, about the IPR implications of the technology that's being worked on, and then it allows for individuals in the working groups to decide whether they want to proceed with the standardization process. So it's not like a one size fits all. And it's true, there's a strong preference in the IETF for royalty-free licenses. And it's, few and far between that you're having these issues come up that really stall out the standardization process. But that's kind of the point. It's like the community preference to have the information and then make their own decisions on a case-by-case basis. So the other thing I think is good about this, thinking about the context in which the IETF sits, is that especially at the higher layers of the stack, when we think about the web and web developers, the model has proven very useful because there's this extremely vast and diverse set of companies and developers working on web technologies, working in open source, these things are unencumbered, and as a result we've been able to attract a much wider pool of participants because they know that they're not having to deal with thinking about the licensing implications of the technology. So that, I think, has really been quite a benefit. I think it also provides some flexibility for those who are seeking to monetize SEPs, because they can contribute their innovations to the IETF. They can declare their patents, and if they get consensus to include those innovations, then the pool of implementers, given that the thing is going to be standardized, is likely to grow. So I think that's a good thing. But they can also choose to not participate and see what happens. And in areas that are really rife with patent activity, the likelihood that you end up with something in the standard that is patented could still be quite high, and they can still benefit from that. So to me, this was I think, as maybe I mentioned to you before, coming into the IETF from this think tank orientation where we had no IPR at all, this was always like kind of a foreign part of the process to me. And I was always pleased to see that we didn't get too hung up too often on these debates, because I think as a general matter, the disclosure policy works well. It draws in a set of folks that wouldn't otherwise be able to participate if we had a different regime. And I think those who rely on SEPs for monetization, find ways to work within the process as well.
Great. Well, that's interesting to hear. And I think so too. It sounds quite flexible in any direction. I haven't heard about too much IETF SEP licensing also, to be honest. So I don't know if even those that, not declare them as royalty free really make a licensing program out of this. This is also a lot of work to do. So, but maybe they keep that option open. One other question that is always part of standards development, and you said that in the beginning, it's a competitive process also, right? You have companies that are competing, joining these meetings, even though it's a very open innovation process. They work together, which is great, but still there's competition here. There's also competition among standards or certain protocols or models. You once mentioned the Ietf Young data model competing with the open config model. What makes the standard superior, and in your opinion, which is typically the solution that wins or is becoming the most preferred solution? Is it the one that is really supported by most of the members, or is it the one always about the technical merit? What makes this standard successful in your opinion?
So the first thing I will say is that there's lots of good jokes out there about the multiple competing standards, and like if we don't have one standard that solved everything, let's make a new standard. The old XKCD kind of joke. But that in many cases you have multiple different standards that are serving the same or similar function, and that can be a good thing, and that's okay. And it's not always something that you're trying to eradicate. And so I think that the sort of Ietf Yang models and the open config models are potentially one example of this, where they serve similar but not necessarily exactly the same needs. If you want the kind of greater expressiveness and software tool chains that are built around the Ietf Yang models, you use those. If you are, have more narrow use cases, you use the open config models, and people use them, simultaneously, sometimes in the same product or the same deployment. So it's not necessarily that just because you see two standards that are aimed at the same objective that you should view that as a failure. It could be a success. But I think in the Ietf, we've learned a lot in the last 20 or so years about what makes a successful standard when you're trying to have sort of internet-wide reach and scope. And this came about, going back, I guess, at least 10 years now, where people started to say we were going to work on a new version of the HTTP protocol, the web protocol. And everybody knew that in order to convince the big web properties and the big web browsers that that this new protocol should be deployed, it needed to do something for them that the old protocols weren't doing. And in this case, the real insight was to start to tie performance improvements to security improvements. We knew there's a very strong security culture in the Ietf. We knew that there were security problems on the internet and the web that needed fixing, and we knew that if all that was offered by a new protocol was the security fixes, that they were unlikely to get adopted. But if at the same time we could say, hey, this protocol is going to make your web connections much faster. It's going to make them 10% faster, 20% faster. That there would be a better incentive to actually get these protocols deployed. And at the same time, we built in all the new security technologies. So you're going to get that as part of the package without even having to think about it. And this model of thinking about the deployment incentive and baking it into the design of the protocol has driven much of the development of standards and security and applications and transport in the Ietf for the last 10 years as a result. And it's a model that we just keep repeating over and over again. So that's one thing. The other thing I would say is really looking at the deployability of standards, right? So there's a lot out there of what we call dead tree standards that are written on a piece of paper, you print them out, you put them in a drawer, you never think about them again. And there's some people who are incentivized to write these things for various different reasons. But in the Ietf, again, a very engineering-oriented culture, we're not super interested in the dead tree standards. We want standards that are going to get deployed on the internet. And that means that has meant a shift over time from designing, the protocol that, sitting in an ivory tower, if you got to design it exactly the way you wanted it so that it was perfect, that's kind of, something that used to happen more often. Now we look at all this huge deployed base, billions of devices that are out there on the network, lots of different kinds of configurations, and you've got firewalls and you've got gateways and load balancers and all these different devices that are in the middle of the network that your new protocol potentially needs to pass through these devices and still get to the other side. How are we going to make that work? And so we've really tried to incorporate data from large-scale testing in the design phase of the protocol. Before we standardize it, we go out there and say, let's deploy this thing to millions of nodes and see what happens. Does it actually do what we think it's going to do? And we feed that data back into the standardization process to figure out, is this the right design? And it's hard for me to understate how much this has changed the design of some of the protocols solely for the purpose that, we really want this thing to see wide deployment. And so that's like a mindset shift that has taken place and is really important, so that we have fewer and fewer of the dead tree standards, and we have more and more instances where we take our collective effort and we put it into something which is actually going to see wide deployment.
Yeah, that makes a lot of sense to me. It's like a product. You need to understand the demand first before you design it. And then if you have testing and user testing in there, it makes it much more likely that people adapt it and use it. I mean, same as our own software. We do so much pilot customer testing and, these kind of, understanding our market and who needs what in a software. I think it sounds very similar in standards development, that this is really how this is approached, that really people want this to be used in the market and highly deployed. So that makes a lot of sense to me. Great, Alissa, this was really good. Thanks for elaborating on all these topics. That makes a lot of things much more clear to me, as I'm not an expert in the whole standards development, more in the IP part of it. So this has been really great. As always, I give my guest on this podcast a chance for the very last statement to provide some insights, what you want our audience to keep remembering from you. So it would be great if you could give us your final words, Alissa.
Sure. So I think we spoke about this before. There's just incredible diversity in the standards ecosystem. And I think that's something that's really overlooked for those who are coming to standards anew. You hear these like blanket pronouncements about particular companies or countries that are winning or losing in standards, or dominating or falling behind. And all of that just ignores the complexity that is true in reality. So that's one thing that I really hope people will remember. Also, that diversity is itself a virtue, that you don't want every SDO to be organized the way 3GPP is, or Ietf, or W3C, or anyone else. And trying to extrapolate from these individual examples is actually a bad idea. Even though it's harder to understand the complexity, it's worth it to understand the complexity. So that's what I hope people remember when they start to see these like oversimplified narratives about standards that are cropping up more and more out there in the world.
Thank you so much. This was Alissa Cooper, Chief Technology Officer for Technology Policy at Cisco Systems. Thank you so much, and I hope to see you soon, Alissa. Take care.
Thank you.